Welcome everyone to the Python with Magicbit Day 5 program. Today we are going to discuss the remote controller activity using Magicbit and Python. We are going to use the MicroPython language in the Tony programming IDE and with the use of Magicbit. So first you need to upload the MicroPython firmware to the Magicbit using the Magicbit web uploader. The link to the web uploader is mentioned in the description box below. You can use that. After uploading the firmware, then you have to open the Tony IDE that is installed in your computer. And after opening the Tony IDE, then you have to connect the Magicbit with the Tony IDE. So let's do that. So when you open the Tony IDE, it will look like this. So here you have to go to the run option and click on configure interpreter. And here it should like MicroPython ESP32. If it is not there, you have to select it left. And here you have to select the port or the WebREPL. You can select the available USB serial port, or else you can select the option try to detect the port automatically. Right? And then click on OK. Then you will see once you click on OK, this red color text will disappear and this green color button will apply or will appear to select. Right? Now both the things happen. That means our Magicbit is successfully connected with the Tony IDE. So after connecting the Magicbit with the Tony IDE, let's see what we are going to do. So we are going to do a remote controller activity. That means we are going to use the Magicbit as a remote controller, or else we can say it like a joystick. I think most of you know what is meant by a remote controller or a joystick. So we are going to use our Magicbit as such a device. So basically in our activity, we are going to control the onboard LEDs in the Magicbit, which are in the back side of the Magicbit, just like I have marked here. We are going to control these LEDs using the two push buttons in the Magicbit. In the front side, either sides of the display, you can see there are two push buttons in the Magicbit. So using those two push buttons, we are going to control the LEDs on the Magicbit. So that is why I told this activity as a remote control or a joystick. In remote control or in joysticks also, we are controlling everything by pressing buttons or by moving or handling that joysticks. No? So that is why we use that name here. As we are going to use the push buttons, let's see how this push button works. So this kind of push button is, two push buttons are connected on the Magicbit. When you press that, the internal, there are 4 pins for the push button. So the horizontal ones are internally connected like marked here. And when you press it, the other two connections will happen when you press it. And when you release it, the internally connected ones are keep same. And these two connections will lose their connection. That means there's no way to pass the current through these connections at the phase of release. When you press it, these connections will occur and it will complete the circuit to pass the current. So that is what is basically happen within the push buttons. Right. So in our activity, we need to make the code using the MicroPython language in order to activate the push buttons and in order to handle the LEDs. So as like what we did in previous sessions, first we need to do the importing of the libraries. So here we are just using the two common libraries, the machine library and the time library. Without importing the whole library, we are importing the necessary classes only. So from the machine library, we are importing the pin class. And if you need to display something on the display, you can use this I2C class as well. And from the time library, we are importing the sleep class. So here in the Tony, we are importing from the machine library we are importing pin. For the moment, I'm not going to import I2C part because I'm not going to print anything. If I need later, I will do that. And then from the time library, I will import the sleep class. So after importing the libraries, then the next main thing we have to do is to define the pin numbers for the components. As I told you, we are going to use the 4 LEDs in the Magicbit. So you have to define the 4 LEDs with 4 identical names for them and the pin numbers and their mode. That means whether it is output or input. At the same time, as we are going to use the push buttons in the Magicbit, we have to define the pin numbers for the push buttons as well. So you can go for the Magicbit pin now to see what are the pin corresponding to these components. Or else if you look at the Magicbit, then also you can see the relevant pin numbers they have marked. And please clearly identify that these LEDs are going to use as the output pins and push buttons are going to use as the input pins. So now let's define those two. So we'll make some common names for the LED. So I will use LED1, LED2, LED3 and LED4. As we have imported the pin class from the machine, so we can directly use that pin class and the pin numbers. You are already familiar with the pin numbers for the LEDs because we have used them in our previous lessons. And LEDs are out. We are taking outputs from the LEDs, so we are defining that one as well. So, and as this is the same format for all the 4 LEDs, I will copy it and paste it for another 3 times, and I'll change the name of them to become identical, and then I'll change the pin numbers of each, and that pin mode is common for everything, so I will keep it same. And then I am going to define the 2 push buttons in the Magicbit. So for the left push button, I will use L, capital L underscore button. So you can use any name to name, right? You don't need to use the same names that I am doing. You can use any name. And left side push button is with pin number 35. That is marked in the Magicbit as well. If you look at the Magicbit or Magicbit pin out, you can find out the pin numbers and it is going to be an input. So we need to define it as in. And for the same, actually the same pattern will come to the right push button. So I will copy that line, paste it, and instead of left, I will mark it as right. And here now it is not 35, now it is 34 and pin in. So after defining the pin numbers, so this is the pin out. Here also you can check the pin numbers. So left push button pin number 35, right push button 34. Or else you can check it out from this side as well. For the LEDs, these are the pin numbers and these are the pin numbers for the push buttons. Okay, then in the program we have to define, if we are going to run the program repeatedly, we have to do the calling of the function. So the rest of the code under this while through. So while through, because I need to run the program repeatedly. And also there are 2 types of push buttons. Pull up resistors or the push buttons, pull up push buttons or pull down push buttons. So the resistor also the same thing like the push button. So what is the difference between this pull up and pull down is, in the pull up resistors or the pull up push buttons, when the button is not pressed, it is having the digital state as high. Output is high when the button is not pressed. And when the button is pressed, its digital state becomes low or the zero. In the pull down push buttons also having the same condition in the opposite way. That means when the button is not pressed, the output state of the push button is low. When the button is pressed, output state is high. In the pull up, when button is not pressed, it is high. When it is pressed, it is low. In pull down, it is opposite. Here in the Magicbit, we have two push buttons. Those push buttons are pull up push buttons. That means when it is not pressed, their digital state is high or 1. When they are pressed, their digital state becomes 0. When we program the push buttons, we definitely know whether these push buttons are pull up or pull down. So according to that, we need to check for the digital state in order to get function with the outputs of the push buttons. So first we need to set the conditions to check the values of the push buttons. Here we are setting the conditions using the if else condition. So we use 3 conditions. First one is we are checking the value or the digital state of the right push button. If it is equal to 0, that means its state becomes 0 or low when it is pressed because it is a pull-up resistor circuit or pull-up push button. And if this is happens, we set some statements to do. And then as the second condition, we'll check the state of the left push button, whether it is equal to 0 or low state. That means then we can identify the left push button is pressed. And then the third condition will check else. That means if something happens beyond the above 2 conditions, that is comes under this else part. So these are the 3 conditions we are defining. So first condition will check if right push button, you have to use the same name that you have named here, right push button dot value, because we are checking the value of that one, whether it is equal to. When we are checking for the conditions, equal sign is come with 2 equal signs in order to indicate that as the normal equal, right? So equal to 0. That means whether it is pressed or not. If this is pressed, then what we need to do, we will define that later. And I will come to another line. And then I will define the second condition if left push button status or the value, whether it is equal to 0. That means whether the left push button is pressed or not. And there also we'll check for some statements if that condition is satisfied. And then we'll use the else. That means if above 2 conditions are not satisfied, then rest of the things should come under this else. So after defining these 3 conditions, then let's check what are the statements we are going to do for this state condition. So if the right push button value is 0, that means if the right push button is pressed, so I need to print the value of the right push button in the serial monitor of the Tony IDE. That means whether it is pressed or not. If it is pressed, it will print 0. If it is not pressed, it will print 1. And when the right push button pressed, I need to happen some LED pattern. So I will keep 2 LEDs off, 2 LEDs on, and after waiting for 0.5 seconds, that means half of the seconds, then I will need to switch off the earlier turned on LEDs and switch on the earlier turned off LEDs. And this pattern should goes if I press the right push button. So turning on and off of the LEDs are done here. So first I need to print the push button value. So here in the condition, so I will use the print command in order to print it. Print within brackets right button dot value. I need to print it, and at the same time I need to turn off the LED 1 dot off, and I need to turn off the LED 2, LED 3, and I need to turn on LED 2, and I need to turn on LED 1. So this should be simple, not capital. And I need to wait for 0.5 seconds. So I will sleep for 0.5. And then I need to do the opposite of these 4. So I will copy them and paste here. And I'll change the LED names. Instead of 1, put 2. Instead of 3, I will put 4. Instead of 2, I will put so I have made a mistake here. Instead of 2, I will put 1. Instead of 1, I will put 3. And again, after 0.5 seconds sleep, so this thing will happen if this condition is true. And if the second condition is true, then I need to do another pattern. If the second statement happens, then I need to do another pattern. In that case also, I need to print the value of the button. So I will use this first command to print the value, and then I will turn on all the 4 LEDs, wait 0.5 seconds and turn off for all the 4 LEDs. Again, wait for 0.5 seconds and do this thing again and again if the left push button is pressed. So without typing again, I will copy all these, one of this whole set and paste here, and I will just change the on and off. First, I need to turn them all on, and then I need to turn them all off. Right? And if these two conditions are not satisfied, then we should go to the else. In that case, if these push buttons are not pressed, in that case, I need to keep all the 4 LEDs off. So I will copy this whole section and paste it here to keep all the 4 LEDs off. Right? So that is the program of our remote controller. What we did was we imported the libraries, and then we defined the pin numbers and their pin modes, whether they are outputs or inputs. And then we define whether we are going to run the program repeatedly or not. If it is repeated, we use this while through, and then we set some conditions. First condition is we are checking whether the right push button is pressed. If that is satisfied, we'll print the value of the right push button, and then we turn and off the LEDs as our wish to create a pattern. Right? In the second condition, we check whether we have pressed the left push button, and then if that condition is satisfied, we'll turn on all the 4 LEDs, wait for 0.5 seconds and turn off them. This loop will go until the left push button is pressed. If the above two are satisfied, then it will check for the else. That means all the 4 LEDs are turned off. Now it's time to run the program. So as we have already connected the Magicbit between this Tony IDE, we can just click on this run button and see the output. When you click on run, if you are getting this kind of output, that means your program is running. Now from your Magicbit side, what you have to do, you have to press the push buttons one by one and check whether the given patterns are working. Okay, now the push buttons are in the other side. So I will turn it to the other side. And from my hand, I am going to touch the push buttons here. This one is the right push button. When you turn it to the other side, it becomes this side. It becomes this side. And here we have in this side, here directly below this, we have the left push button. Here, directly below this side, we have the right push button. Now, if I press the right push button, what is need to happen? Two of these four LEDs will light up and it will switch after voice pulse. Let's see. Okay, I release my hand from the push button. So now no. That means the else condition is running now. So there we called all the four LEDs to turn off. Now if I press the right push button again from this side, I am pressing it. Four LEDs are out of the four. Two of the LEDs are lighting at same time. Right? Okay, now I release my hand from the right side. Now I am pressing the left push button. Okay, now look at the different, there will be a different pattern here. See, if the left push button is pressed, we call it to turn on the LEDs and turn off all the four together, just like blinking, right? So like that, you can create different patterns to switch by using the left push button and right push button. So that means we can use this Magicbit as a joystick or remote controller kind of thing to control with LEDs. Not only LEDs, but also you can go for some other uh, to display something on the display, to switch between the points when we press the push button. So the output you are going to have, that is up to you. What I need to explain here is how to use the push buttons in the Magicbit using the MicroPython language. That's all for today. So we'll meet on next week from a new lesson. Thank you so much, everyone. If you would like to know about So that's all for today. So we did our code like this. We did our remote control activity. If you would like to learn or know more things about Magicbit, you can visit Magicbit official website as well as the Magicbit YouTube channel. So all the links to the previous lessons in this program are mentioned in the description box. You can watch the previous lessons from them. Thank you so much for joining with us. Let's meet on new lesson.